What about when you ask to find the limit of the function when x goes to negative infinity, when you do not have any top or bottom functions to compare with, right? Or when you try to plug negative infinity into a function, it doesn't make sense. Well, think about if you look at this example specifically, you have a radical functions. And if you have a radical functions, you always want to think of is conjugate. So in this case, let's start with multiply the function by its conjugate. And to reserve the equivalency, we want to divide the function by the same term. Well, if you multiply the numerator together, you get 4x squared plus x minus 4x squared. Then you can cancel the 4x squared out to get x over square root of x squared, 4 plus 1 over x minus 2x. Here we wanted to factor the x squared out in the denominator because we want to move the square root x squared out to see if we can cancel any of the term later, right? And then at this point, you want to pause the process. Think about what we want. We want x goes to infinity. You want to find the limit when x goes to negative infinity. That means you want to evaluate the function at the negative side. I mean, x will go to a very big negative value. In order to guarantee that, we should replace x by negative absolute value of x. It's because you know that absolute value of x is positive. You add a negative, you make sure that you have a negative value there. All right. And then, you can replace this x by negative absolute value of x and this x by negative absolute value of x. And to reiterate the fact why we want to factor x squared out is because we know that we can move it out of the radical using square root of x squared equal to absolute value of x. Put everything together, we'll have a slightly new function. Negative absolute value of x divided by absolute value of x times the square root of 4 plus 1 over x plus 2 times absolute value of x. Now we have absolute value of x in every single term. You can just cancel that term out. That will leave you negative 1 over square root of 4 plus 1 over x plus 2. Or at this point, I want to ask again, can I plug negative infinity into x to, figure something out? And if you, in one of the x functions, if you plug negative infinity into x, you get 1 over negative infinity. And you know that you have in the limit word, right, the denominator is going to infinity and the numerator stay at the constant, then the value should be 0. So if I plug negative infinity to x, I got 0 for 1 over x. So then my limit will be just negative 1 over square root of 4 plus 0, which is square root of 4 plus 2, which would give me negative 1 over 4. And if you look at the graph of the functions, this function, you see that we have a horizontal asymptote, y equals to negative 1/4. So that means when you look to the left, when x goes to negative infinity, the function goes toward to negative 1/4. And if x goes to positive infinity, the function goes to positive infinity.